So strain stress is very similar. We are now working with entire, like we're not like giving our entire limitations to strings and wire only. We can work with any kind of object that has area, right? Area means that have like multiple dimensions on it, 3D objects. So since they will have area and volume. So for stress basically measures the, like in order to compress it or maybe like pull it, you have to apply a force, right? And that force acts on a specific amount of object. So you can calculate stress using the equation force over area. Now there was another quantity that involves the same quantities, like another kind of quantity was calculated using the same equation. It was force over area. Can anyone please tell me what was that quantity? Whose equation was also right? Pressure, right? Now what would be the difference for pressure and stress? Is there any difference between pressure and stress? I mean, we're not in literature class. Right. Yeah, obviously, that's logically correct. If you're under pressure, you get more stressed. But in physics, that also works like that, that if you're under pressure, you will get more stress. But they have different meanings. For example, if I draw a simple kind of graph to explain the entire scenario for stress. If you're working with two cubes, maybe, so it is kind of clear that there is a smaller cube on top of a second bigger cube. So we're going to label this as cube B and this as cube A. So now obviously as cube A is on top of cube B, cube A is applying pressure or stress on cube B. Right, so obviously we have understood by the term that if the two objects are in contact, they will obviously apply both pressure and stress. Since object A is on top of B, object A will now be applying both pressure and stress on object B. So how can you differentiate between the pressure and stress? For example, if you were to calculate pressure, the equation would be we are trying to like the normal basic equation for pressure is force over area. Now force like what kind of force are you going to use for this scenario? It's basically the like force is basically the weight for the object A. So the it will be weight for object A, and for what area the force is getting like applied on object B, that is for this much area, the a cross-sectional area for object A. So area will be cross-sectional area for object A, right? Cross-sectional for object A. And now in order to calculate the value for this stress, we are going to use the same equation, force by area. But this time the force is again weight of object A, because object A is the one applying force on object B. So weight force will still be the same, weight of object A. But this time this amount of force is acting on object B, right? So we are now going to use the area for the object B. So the area for the object B is basically the cross-sectional area for object B. This was the cross-sectional area for object B. So cross-sectional area for object B. So the only difference is between the area. The force is same, the same kind of same amount of or same type of force is acting for both pressure and stress, but for cross-sectional area, for pressure we are just working with the one that is applying the pressure on another object, and for stress we are using the area on which this stress is being applied on. For example, the stress was being applied on B, so we are going to use the cross-sectional area for object B, and for pressure, the like pressure was applied on B, but the cross-sectional area is going to be for the object A. Is this clear, the difference between pressure and stress? In some questions, they will actually ask you that, like there could be multiple objects connected to it, and they would ask you to calculate stress. And that time you might get confused at whose area you're supposed to take. So you're always supposed to take the area for the object on whom the stress is acting on. So any problem for stress? Right, they will give you the values for the area, or you have to like calculate the area. Like if it is a cube, then use like formulas for square, or if it is a rectangle, then use the formulas for a rectangle. So if I give you a numerical value, if the area for these like A, area for A is around 12 centimeters square, and if the area for B is around 13 centimeters square. So for the pressure equation, you're going to use weight for A divided by 12. That was the area for object A, or the red shaded part. And for stress, you're going to use the equation weight for object A again. But this time, you're going to use the area for the object B, that is 30. So 30 centimeters square. Is it much clear now?